Welcome to choosing a repository for your research data, everyone. I'm Janice Masood-Paul. I'm the health sciences librarian. I'm going to start by stopping my video so you'll be listening to a disembodied voice for a moment. But please, if you have any questions at any point, there are not a lot of us, just turn on your mic and ask a question, or you can wait until the end of this presentation. And if you have any comments or anything to add about my content, just jump right in and add that information. So, okay, so this afternoon, we're going to cover recent changes in the research landscape. We'll talk about why you need a research data repository, some FAIR principles and other selection criteria, types of repositories, and how to find a repository. The last time I did this presentation, it was about 2 years ago, and the research landscape has had some significant policy changes since 2020. So notably, there were advantages of sharing data and research output. They were magnified by COVID research, which showed how immediate public access to data could result in life-saving collaborations. There were also updates to the NIH research data management and sharing policies that actually take effect today on January 25th. And they're affecting the growth of repository options. So this webinar isn't linked to just NIH grants and their policies, but I wanted to point them out because they're going to have a direct impact on other funders. Many of the repositories that NIH recommends can be used for output from other funders. And then finally, there's the Nelson memo from the Office of Science and Technology, and that encourages access to research by requiring federal funders to update their public access policies by the end of 2024, with implementation dates of no later than 2025. Their grant recipients should be guided to provide free and immediate public access without embargo to research papers and data in agency-designated repositories. So why do you need a research repository? Well, I just addressed the push from grantors to share research and output, but there may be other reasons you need a repository. Increasingly, journal publishers also require data sets to be made available when the article is published or when the grant period is complete, whichever is sooner. And this isn't really anything new, there's just more publishers requiring that. Even if your research isn't associated with a grant or cases where a repository may not be explicitly required, you may want to share your research and data. Just posting it to your website typically won't provide the same discoverability or ease of access. And because research data repositories provide reliable long-term storage and access to research data, you may want to use a repository to ensure your data is secure, properly archived, and preserved, even if you don't plan to share it. So what should you look for when you're choosing a repository? Well, funders and publishers may have specific requirements, and it's important to follow them closely. You want to check the grant funding opportunity announcements because they may designate which repositories you can use. But even if they suggest repositories, you may want to consider specific criteria. So things like, can a repository manage your file type? And are there file size restrictions? How many files will your research generate? What's the cost of storing your output? There may be ongoing repository costs after you deposit your data. Have you accounted for those long-term costs in your grant budget? And in general, you should confirm that the repository incorporates FAIR principles to make the data findable, accessible, interoperable, and reusable. So I want to look at some of those criteria in a little bit more detail. The data is findable if it's uniquely and persistently identifiable. Does the repository register your data to create a persistent identifier like a DOI? Does the repository provide for rich metadata that will help other researchers discover it? Will your research output and data be indexed in Google or subject databases? The data is accessible if it can be understood by either machines or human beings, and they can get to it through standard protocols that allow for authorization and authentication if necessary. Your data objects are interoperable if the metadata and data are machine accessible, and those machines can speak to each other using standard and preferably open formats and share technology. And the data objects are reusable if the data can be automatically linked to the source and the source is properly cited. It's really important that any licensing and terms of use for your data are upfront and clear. Now, ideally, your repository, if you can find one, should be free as long as it meets your criteria. Unless you utilize a government repository and institutional repository, there could be ongoing costs. But costs may be supported by the grant budget. So, for example, in the new NIH policy, data management and sharing costs may be included as part of the budget, including costs associated with curating data and preserving or sharing data through established data repositories. But the grants will only pay for associated costs before the end of the award period. So see if you can be invoiced in advance for those costs so you can include them in your grant. Now, what if you're collaborating with other institutions, but you're not the PI? Are your collaborators willing to use a free repository? Can they use their institutional repository to store your output for free? If they're not willing to do that, perhaps they can cover the cost of storage or preservation for your data. So the NIH has provided updated guidance on desirable repository characteristics, and I really recommend viewing those, even if you're working with another funder. A lot of the characteristics are very similar to what I mentioned in terms of FAIR principles and costs, even if the wording's different. So things like unique persistent identifiers, making sure you have good metadata, free and easy access, and so on. If you're interested in learning more about these individual characteristics, there is a link at the bottom of this slide, and I'll make the slides available after this presentation. So let's talk about the types of repositories. There are several. Some funders host repositories where you can submit your research data when your project's complete. NIH-supported repositories are free, as I mentioned before, and will meet your requirements for NIH and other grants, and they've been vetted for you by the NIH, which is an advantage. Some of these repositories are disciplinary in nature, but disciplinary repositories can also be managed by professional organizations or nonprofits, and those might require a little bit more vetting. Your discipline may have a repository that everybody in your discipline goes to for information on that topic. So, for example, FlyBase is the place for genetic data on fruit flies, if that's your area of research. There's also general repositories like Zenodo or Figshare, and they cover many fields of study because sometimes there just aren't disciplinary repositories that meet all your needs. Or your data of interest may be of interest to many disciplines, and you may want to maximize discovery. And finally, there are institutional repositories that store the research output of an organization. Not all institutional repositories can accept all types of data. So now that you're armed with information on types of repositories and selection criteria, there are several ways you can find a repository if your funder or publisher does not specify one. You may want to consider looking in registries or directories, and we can start with funder directories. So let me click on this NIH link. Okay, so this is a link to NIH's data sharing resources. They're primarily domain specific, and you can see that you can sort this information by institute or by center and whether or not they are available for data storage. Clicking on this link would give you access to different areas. And if you're interested in just using the database for a repository, you can click on the link here. If you're interested in searching for the data, click on the link below. I'm going to stick with the NIH for a moment. As it says here, they strongly encourage subject-specific open access data sharing repositories as their first choice. But if a data repository isn't specified, then you can use discipline-specific repositories. If no discipline or data type specific repository is available, you have a number of other options, and sometimes that's based upon the size of your data. So let's say you have a small data set that is connected with an article. If it's under 2 gigabytes, that can be connected with PMC, which is the PubMed Central repository, and all of that information, the article as well as the data, could be stored there. But if it's larger than 2 gigabytes, you may want to consider one of the generalist repositories that can store up to 2 gigabytes. And I'll talk more about them in a moment, but they're part of the Gray Ecosystem Initiative. And then finally, if you have really large data sets like petabyte scale, then you would want to consider some of the cloud-based data repositories, and they recommend Amazon Cloud, Google, or Microsoft, but that is going to cost you. There are general repositories supported by the NIH. About a year ago, NIH launched the Generalist Repository Ecosystem Initiative, or GRAY. And GRAY includes 7 generalist repositories that work together to establish consistent metadata, develop use cases for data sharing, and to train and educate users on FAIR principles and the importance of data sharing. The repositories that are included are the Dataverse Project, Dryad, Figshare, Mendeley Data, OSS, Vivuli, and Zenodo, and these are established repositories that I'm sure you've heard of before. They can be used not just for NIH grants, but basically any grant. There's a comparison of the different features of these repositories, because even though they're all part of the same initiative, they vary somewhat in terms of the amount of data that you can store and possible costs. So there's a link to that comparison at the bottom of this slide. There are, of course, disciplinary repositories that are outside of that NIH list. And one well-known repository is called Dataone. In this case, it's not a repository, it's actually a registry. So when you look for information in Dataone, it's going to give you a list of registries, or excuse me, a list of repositories that will meet those criteria. So it's primarily for bioscience repositories. I did a search on climate migration, and it provided me with a list of repositories that store data sets on that topic, along with geographic indicators for the location of each study. If you can't find a suitable repository in a disciplinary registry, you can try a general registry. An example of that would be RE3 Data. This is a global registry that includes data repositories from various academic disciplines. I did a keyword search on COVID, And I did this a little while ago because otherwise there would be a lot more results. But that yields repositories related to COVID-19. I can limit by content to find repositories that accept audiovisual data, databases, raw data, source code, and so on. And then I can select data access filters, and they indicate which repositories accept data with access restrictions, like embargoed data or closed data. And then there are institutional repositories. So Drexel Research Discovery is our institutional repository, and that provides access to research and scholarly outputs created by Drexel faculty, staff, students. It includes things like dissertations, theses, journal articles, conference papers, and proceedings, and posters and research data. Now, this is a recently acquired product, and we're testing policies for ingesting publications. If you have research output, like articles and their associated data, and you're interested in possibly submitting your output to our repository, let the librarians know, and we'll be happy to discuss options with you. Publishers also have directories. There are many of them, but I just have one example here. Scientific Data is a peer-reviewed open access journal with descriptions of data sets and research that advances sharing and reuse of scientific data. They mandate that you share your data, but they don't host it themselves. Instead, they have an evaluated list of data repositories to ensure that the repositories meet requirements for data access and stability. So I'll just click on this for a moment so you can see the type of information that's available to you. They provide a list of generalist repositories, but if we scroll down through this list, you can see that there are subject repositories available as well. So given the time, I'm just going to move on to my last slide. We talked about why you need a research repository, the types of repositories available, criteria to consider when you're choosing a repository, and how to find a repository that meets your needs. So if you have questions, please feel free to contact me by email at jhm52. And I encourage you to view our Research Data Repositories Library Guide, which you can find at the address on this screen at the end of the slide.